Hello there and welcome. On the previous module about pharmacokinetics, we learned what the body does to the drugs, to elimination, excretion, so forth. Now we are going to look at the different aspect of what the drug does to our body, and that is pharmacodynamics. Okay, so let's delve on it. This is our training number 8, our roadmap. It's about pharmacodynamics essential. So, pharmacodynamics is the study of what the drugs action on the body, our body, including how the drugs interact with receptors, ion channels, and enzymes. It helps us understand what drugs do to our body. Guys, I cannot emphasize enough that you need to know the difference between pharmacokinetics and pharmacodynamics because test makers love to confuse those two topics, know it by heart. Okay? You may see this again, so please know this concept by heart. One example of pharmacodynamics is an increase in neurotransmitters, right? Action in the synaptic cleft because it can improve the neuron communications. Another example is combine SSRIs with NSAID, aspirin, and protein carriers may increase the risk for bleeding. Now, pharmacodynamics, how medication usually exert their effect through one of the seven mechanisms. I want you to focus specifically on the agonism spectrum here. So it's the agonist on one end and the inverse agonist on the other. But let me specifically talk about the agonism. When you hear the agonism, it activates a receptor biochemical to produce a biological response. For example, when the morphine mimics an endorphin by binding to opioid receptors and producing pain relief. All right, this is a very important concept. Please make sure that you know that agonism produces a biological response. Here again, the spectrum, pharmacokinetics. Again, think about partial agonism, right? If an agonism makes it a biological response, the partial agonism binds to the receptor but does not fully activate. It activates just some, results in a muted or less potent biological response. So it does affect the receptor, but not as much as a full agonism. For example, bupropion binds to opioid receptors but has lower efficacies than the full agonism like morphine, making it less helpful manage opioid dependence. So now you know why buprenorphine it's usually helpful in managing opioid dep- dependency. Now, we talked about the agonism, the partial agonism. Now, let's talk about the inverse. The inverse agonism is not the same thing as the antagonism. Inverse agonism is not the same thing as antagonism. Don't get those mixed up. When we talked about inverse agonism, it binds to the receptor as the agonist, but it induces a opposed biological response, effectively causing the reverse effect of a agonism. For example, the inverse agonism for benzodiazepine can cause anxiety and convulsion instead of relaxing and sedation. The antagonism, on the other hand, it blocks a receptor to inhibit the biological response. It inhibits the biological response, preventing the endogenous agonism from binding and exerting their effect. So the inverse agonist is the same concept as the agonist. However, the inverse order. It does produce a biological response. The antagonism, it doesn't. It just binds it and block. That's it. Okay? Don't get them confused, guys, please. So one example of antagonist is the naloxone that acts as an antagonism at opioid receptor, reversing opioid overdose symptoms by blocking those receptors. Okay, so important concept. So I mentioned there were 7 ways. Okay, so I'm going to mention the other ways. It's not necessarily something that's high yield, but you as the practitioner, or you that are transitioning, you need to know the other 3. So ion channels is another way. The substrate may lack the various ion channels in the potassium, sodium, and calcium and chloride rather than the receptor sites and exert an inhibitory or excitatory effect across the cell membrane. So if you are one of the students that are part of the psychopharmacology class, we go in detail on module 1 of the 7 ways in which drugs affect our body. Okay, and the ion channels, it goes more in detail with the depolarization and repolarization. Okay, not very important for the board, so kind of keep going along here. The other way that drugs exert its effect on the body is by enzymes inhibitor, right? The the catalytic action of an enzyme is slowed or stopped, allowing the neurotransmitter to remain in circulation. For example, the monoamines oxidase inhibitors reduce the breakdown and eventually the removal of serotonin, norepinephrine, dopamine from circulation. Okay? Moving on here, we have also the reuptake inhibitors, which you guys are well familiar with, which is hindering the absorption of neurotransmitter by the synapse by blocking the transporter, so allowing for higher neurotransmitter concentration than synaptic cleft. So this is how SSRIs work, right? So basically, the reuptake transporter is inhibited. Therefore, you have more of the serotonin, dopamine, and norepinephrine available at the synaptic cleft. Now, going on pharmacodynamics, pharmacodynamics is what the drug does to your body, and we cover agonism, activate a biological response. Partial agonism, it activates some but not full. Inverse agonism, it's the same thing as an agonist, but in a reverse opposite biological response. And antagonism does nothing. It just inhibits the biological response, preventing a endangerment or inside our own body agonists from binding and exerting their effects. Okay, important concept. Please know this concept by heart. Now let's do a check on learning. What action does an agonist receptor produce? Agonism receptor. Does it do a partially activate the receptor, resulting in a limited activity? Does it prevent the agonism from opening the channel and does not trigger a biological response? C. Does it create an opposing effect to the agonist, causing the receptor to close the ion channels? Or D. Does it initiate a biological response and opens the ion channel? Which option would you take? Well, if you did pick D, you got it correct. So, since it describes what the agonist does at the receptor, it activates a biological response and it opens the ion channel. Okay. So A is incorrect because it describes a partial agonistic. B is incorrect because it refers to an antagonistic which blocks the agonist instead of producing their intended effect, which means no biological response. C is incorrect because it describes a inverse agonist that produce the effect of an agonism, however, is opposed agonist effect. So it closes the ion channel. Important to know these characteristics in detail. Okay? So I hope you learned something on this training. We are moving on to training number 9. I'll see you there. Bye bye.